Everybody, so we will take an example to demonstrate the next point, and this is a very simple process where we have, or it's a process of manufacturing a medicine, and this whatever this medicine's name is, or what are the components that are or this medicine is composed of. We have two components A and B that are mixed together, and we have the product, the needed product flow rate is 100 kilograms per day, and we are told here, and this is the main point here of this problem is that the mixing of A and B is or A and B are mixed in a mass ratio of 220 milligrams of A per 120 milligrams of B. And it's required to know the missing information, which are the flow rates of A and B. So if we try to convert this text into a flow sheet, it's going to be as we see here. It's mass of A in stream 1, it's pure A, and then mass of B in stream 2, which is pure B. We know the product is 100 kilograms per day, and we have XA3 and XB3. So based on this, we can start the solution. But if you look at the number of equations that we can write, we have two equations, one for A and one for B, and the total. But we have two independent equations, and we have the number of variables that we have are 1, 2, and 3. We have 3 variables, 1 composition and 2 flow rates. So the number of equations that we have is not enough. However, there is one thing that we have in the problem statement that is going to be very helpful, which is the mass ratio of A to B is 220 to 120. And this information is a relation between two variables in the problem, and this relation is considered as an extra equation that we can use, and we call it additional relation. So additional relations are just extra information. Without this information, we will not have the ability to solve the problem, because we don't have enough equations. So the additional relations are very important. And as I said, it's a relation between any two parameters. It can be, as in this example, relation between two flow rates. It can be a relation between two compositions, between any two parameters. It can be relation between any two parameters in the flow sheet or in the process. So if we look again at the additional relation, we will see that it's a relation between two of the 3 parameters. So we have one extra equation. It's very important. It's very, very, very important to be able to convert this additional relation into a proper equation. Sometimes it's a little tricky. Sometimes the reader will not know exactly how to translate this into an equation, and of course, if you don't translate this into a proper equation, the result will not be correct. So this is very important. So in this case, we have a relation between mass of A and mass of B, which is MA dot and MB dot. And as I said, we have three variables, we have 2 equations, and we have one relation. So the number of equations plus the number of relation equals the number of variables, and then we can solve the problem. The translation of this, we have the equations of mass balance, MA plus MB, and we have the balance of A, that A in stream 1 equals A in stream 3, because you don't have A here, and the same for B, of course, but B is going to be a dependent equation, so we're not using it. The additional relation states that mass ratio of A to B is 220 to 120. So this is MA dot over MB dot. It's 220 over 120. So now we have a relation between mass flow rate of A and mass flow rate of B. We can use this equation with this equation to have to find the mass flow rate of B, and then we can calculate the rest of the parameters. And this is how the additional relation can help us. So we can calculate MB, MA dot, XA3, and XB3. They are all now known. So it's very, very important to know how to translate the additional relation into a proper equation. By this we are done with the notes that we have to know before we go through the process of finding the the systematic approach of solving the problems, which is going to be the topic of next time, and we call it the degrees of freedom analysis. So we'll go through this next time. So I'll see you then.